The next few examples we're going to look at graphing with a change in amplitude and a change in period. So we're going to look at graphing y equals a times sine of bx, or y equals a times sine of cosine bx. And we're going to go through and we're going to find all of the x values that we need for the graph, and then we're going to draw in our basic shape using the new amplitude. So we're going to look at graphing y equals y equals 4 times sine of 3x. So what we've multiplied on the outside of our function is 4, and b, what we multiplied on the inside of the function is 3. So the amplitude will be the absolute value of that, which of course it's already positive, so the amplitude would be 4. And the period, we take the original period of 2 pi, and since our b is 3, that tells us we complete 3 full cycles between 0 and 2 pi. So we're going to take 2 pi, and we said we're going to divide it by that b value to find the period of this function for just one cycle. So 2 pi divided by 3 will be the horizontal length required to complete one full cycle. And we also want to find the equal distance between all 5 of our key points. So we're going to take the period, which is 2 pi divided by 3, and we're going to divide it by 4, because we have 4 equal segments between each of our key points. And once again, when we do that, we're going to think about this as a fraction, and then we're going to flip and multiply. So that would be 2 pi over 3 times 1/4. And of course, we're going to have some factors cancel. So we end up multiplying across. We have pi, 3 times 2 is pi over 6. So keep in mind that this is not the period, but this is the equal distance between all 5 of our key values. So the distances between those points, those 4 equal segments, are going to be a length of pi over 6. So we're starting at 0, and we're going to make note that we're only asked to graph one period interval. So we're going to do for one of these cycles. So 0 plus pi over 6, and obviously that will just be pi over 6. Pi over 6 plus pi over 6, we get 2 pi over 6. Plus pi over 6 again, we get 3 pi over 6. Plus pi over 6 again, we get 4 pi over 6. And then these are actually our five key points, so we can stop there. We're graphing sine, and we set the period, the amplitude was 4. So let's go ahead and mark off a distance of 4 from the middle, and then going up and down from the x-axis. So we're going to mark off 4 and -4 on our y-axis. Sine is a shape that looks like this. We said starts at the middle, goes to the max, middle, min, and then back to the middle. And so we're going to be stretching that distance from 1 to 4. So at our second key point, we're going to go up 4 units. At our third key point, we're going to come back to the middle. At our fourth key point, we're going to stretch that distance down to the minimum of -4. And then for our last key point, we're going to come back up to the x-axis. And this will be our graph of sine. And notice that the distance here between the middle and the max and the middle and the min is 4 units. And that was our amplitude, and it exists here and here. And notice also that we can reduce these fractions in between. 2 pi over 6 is the same thing as pi over 3. So if we wish to reduce those x values. 3 pi over 6 is the same thing as pi over 2. And 4 pi over 6, of course, is the same thing as 2 pi over 3 when we reduce that fraction. So notice that from 0 to 2 pi over 3, this is one period of y equals 4 sine of 3x. So it goes from 0 to 2 pi over 3. And our equal segments were pi over 6, which is like 30 degrees. And that makes sense when you think about it. From here to here is 30 degrees. Here to here, 30 degrees. It's like this is like 30 degrees. And this would be like 60 degrees, 90, and then 120. So it makes sense even in terms of the degree measures. Each one of those would be 30 degrees apart, or pi over 6 apart. So the key points that we get in between make sense. So that's one cycle. We were only required to do one cycle there. Let's look at the next one. This one we're asked to do a 2-period interval, so we want to graph 2 cycles of this function. One thing we want to notice is that we have a negative angle, a negative value on the input angle. And we said that cosine was an even function, so we're actually going to look at graphing y equals, and we said that a negative on the inside is the same as just a positive of that angle on the inside. So it's almost as if the negative doesn't matter at all when we actually go to graph this function. So remember that for an even function, I'll just write this up here again, a negative on the inside is exactly the same as the function value with just a positive value on the inside. So we're just going to ignore that negative for cosine. So the amplitude here is a positive 1/2. It's the absolute value of a, since a is 1/2, and the b is 4. So we complete four full cycles between 0 and 2 pi. So what is the horizontal distance required to complete just one full cycle? So the original period divided by b, and we get that the period to complete one full cycle, that distance is pi over 2. So what is the equal distance between each of our key points? So we're going to take pi over 2, divide by 4, and eventually what we're going to do is, if we have a fraction as our period, we're going to skip ahead a couple of steps. We know every single time that we're going to divide by 4 every time, and we're going to end up flipping and multiplying that. So if we have a fraction given as our period, we're just going to multiply by 1/4. We're going to kind of make that a little bit faster. So the equal distance between those 5x values is going to be pi over 8. So let's plot our x values. So we have 0 plus pi over 8 plus pi over 8 again. That would be 2 pi over 8. Plus pi over 8 again. That's going to be 3 pi over 8. And plus 3 pi over again, or plus pi over 8 again. We're going to end up with 4 pi over 8. So we had 1 pi over 8 each time. And there's our 5 points that we need. And we're going to stop there, and then we'll come back and do the second period. We have our cosine function, and we said the amplitude was 1/2. So originally we would have gone up to 1, down to -1, but now we're going to go half that distance in the vertical direction. Okay, so let's think about our cosine function. Our cosine function starts high at the maximum value, comes back down to the middle, goes down to the minimum value, comes back up to the x-axis at the middle, and then finishes at the maximum value. So here's our cosine, one period of cosine. And we're asked to do 2 of these, so we'll continue on. And remember that the ending point for one cycle is the starting point for the next. So we're going to keep going, and we're going to add pi over 8 again, so that would be 5 pi over 8. And we're going to add pi over 8 again, so we get 6 pi over 8, 7 pi over 8, and I think we need one more, 8 pi over 8. So here it starts at the max, comes back down to the middle, goes down to the minimum, comes back up to the middle, and then finishes out at the max. So this would be our second period of that cosine function. And of course we can go through and we can reduce each of our fractions. 2 pi over 8 really is the same thing as pi over 4. 4 pi over 8 is really the same thing as just pi over 2. 6 pi over 8, they have a common factor of 2, so that was the same thing as 3 pi over 4. And lastly, 8 pi over 8, that's just the same thing as just pi. So if you wish to, you could go through and reduce each one of those x values. Alright, so here we're asked to graph y equals -5 times cosine of 1/2 x. The amplitude is changed by a. A here is -5. The negative implies that we will have a flip of our original graph. So cosine originally starts at the max, comes to the middle, goes down to the minimum, goes back to the middle, and then goes back to the max. So since we're flipping our cosine function, I'm just going to make a little note that what we're going to end up doing is starting down at the minimum, coming back to the middle, max, middle, and then back to the minimum. So our graph is going to be flipped because of that negative on A. But our amplitude itself is always the absolute value of A, so it's always the positive of A. So it's 5. We're still going to be going up to 5 and down to negative 5. The period, so we have our B is 1/2. Since B is 1/2, we're going to complete half a full cycle between 0 and 2 pi. So how much do we need to complete one entire full cycle? So 2 pi divided by B, which is 1/2. We're going to end up flipping and multiplying by 2 over 1. So we end up with 4 pi. So the length required to complete one full cycle will be 4 pi units. Now let's find our equal distances, and this actually turns out to be pretty simple. We're going to take the period, the entire distance, and we're going to divide it into 4 equal parts. And so we end up getting that the equal distances between those key points will just be pi units. So let's find all of our x values. So we'll have a starting x value of 0, and we're going to add pi to that. So we end up with pi. Then we're going to add pi to that, so we have 2 pi. We're going to add pi to that again, so we end up with 3 pi, and we're going to add pi again, and we end up with 4 pi. So we're only asked to do one period interval, so I can use all that space as I wish. And so our graph is flipped, so we're going to stretch down 5 units. So we're going to start down at the bottom, come back up to the middle, come back up to the max, middle for the 4th point, and for the 5th point we're coming back down to the minimum. So this is our one cycle of cosine. And you notice that we complete half that cycle between 0 and 2 pi, which is what B tells us. And one full cycle is required, one full cycle is from 0 to 4 pi. So we require 4 pi units to complete that one full cycle of cosine. Alright, our last example here. We're graphing y equals 2/3 times sine, and we have a negative on the inside of our angle, so we have negative pi over 4 times x. And because sine is an odd function tells us that a negative on the inside is the same as just bringing that negative to the outside in the front of our function. So this is going to be the same thing as sine y equals 2/3, negative 2/3 times sine, and then we're just going to leave that as pi over 4 times x. So we're going to make the input angle positive and just bring that negative out using that definition of an odd function. So our amplitude, of course, is going to be the absolute value of a, and here a is negative 2/3, but the absolute value of that distance now, will be positive 2/3. And the period, this one's a little different because the b actually is a multiple of pi, so that makes it a little bit interesting. So b is 1 pi over 4, or pi over 4. We're going to take 2 pi, and remember we're going to divide it by b to find the period. So 2 pi divided by pi over 4. We're going to flip that fraction, and we're going to multiply by the reciprocal there. And so what happens is interesting here is that the pi's actually end up canceling out as common factors, and the period just turns out to be just 8. And that's perfectly fine. We don't need pi in our measurements to have radians. So this is a period of 8 radians, and it turns out to be exactly 8 radians without pi being involved. So that's perfectly fine. We don't have to have pi in our radians to actually have radians. So what is our equal distance then between the key points? We're going to take the period, so the entire distance, and we're going to divide by the 4 equal segments to see what is the length of each one of those segments. And this actually turns out to be pretty easy. It's just 2. So the distance between each of our x values will be just 2 radians, or 2 units. So let's take what we have here. Our amplitude is 2/3, so we'll just mark off 2/3 and 2/3. So 2/3 and negative 2/3 is what our graph now will bounce between. And our graph is flipped upside down because of the a turns out to be negative. So let's do a quick sketch of what that's going to look like. Sine originally looks like this for our 5 key points. And we're going to flip that upside down. So what we're actually then going to graph is going low first and then going high for that 4th point. So since a is negative, we have that flipped graph. All right. So we're just going to keep that in mind as we go forward. So we have the amplitude, and we have the period, and we need now to find all of our x values. So we're starting at 0, and the next value would be 2. We're going to add that equal distance that we found there, 2. The next one would be 2 plus 2, which is 4. We're going to add 2 again, we get 6. We're going to add 2 again, we get 8. And there's our 5 key points that we need for one cycle. We are asked to do 2 full cycles, so we will do that in just a minute. Alright, so here's our x values. And we're going to graph sine. We said we're going to start at the middle. And it's flipped, so we're going to go down to the minimum, come back to the middle, go up to the max, and then come back to the middle. So here's one full cycle of sine. Okay, we're asked to do 2 periods, so a 2-period interval. So I'm going to keep going one more time. And our equal distance is just 2, so that's going to be, our next x value would be 10. The next one would be 12, so we have 1, 2, 3. The next one would be 14, and the last one would be 16. Remember that the next cycle starts where the last one ended. So we end up starting at the middle, going down to the minimum, coming back to the middle, going up to the max, and then coming back down to the middle. And I didn't give myself quite enough room there, but that's okay. Drew a little bit better there with the curve. So here's our 2 full cycles of sine. It goes from 0 to 8, and then the second cycle goes from 8 to 16. But notice that the period for the first cycle, that's 8 units, and the length required to go for that second full cycle is also 8 units, or 8 radians, since these are angles measured in radians.